Today I'm going to tell you a little bit about where we can find radioactivity. It's all around us, and we're going to talk about transmutation and half-life. Okay, so we can find radiation pretty much all around us. So these are some of the examples of places that we encounter radiation in our everyday life. So some places are probably obvious. For example, X-rays. I think you can assume that you're getting some amount of radiation there, but we also get some amount of radiation from the sun. If you go on a flight, you get closer to the sun and you get exposed to some radiation there. And then in different foods, there are natural sources of radiation all over the place. So radiation is not something necessarily to fear, but something that we're going to try to understand more. In high doses, it can be a problem, but we encounter radiation every day all around us. All right, so transmutation is something that you've looked at a little bit already in class. When we did the simulation with alpha decay, for example, you saw that a given nucleus, the one we did in class was polonium, when it loses an alpha particle, it becomes lead, and that's because it loses 2 protons. So if we change the number of protons in the nucleus, which happens both in alpha and beta decay, then we end up with a different element, all right? And that process, converting one element to a different element, is called transmutation. In class, we also looked a little bit at how this happens and how quickly it happens. So the more radioactive something is, the shorter its half-life is going to be. So a half-life is the amount of time it takes for 1/2 of the element to decay. So for example, polonium-211, which we looked at in class, has a really short half-life. The half-life of that is 1/2 second, whereas carbon-14 is another radioactive element that we're going to look at next in our next lesson, and it takes 5,730 years for half of it to decay. So you can see that there's a huge range in the half-lives of different radioactive isotopes. So now the question is, how do we use this information? So if we have a radioactive isotope that has a half-life of 1 day, then how long or how much will remain after the end of the second day? So in day 1, that's 1 half-life, and so that would leave us with 50% of our sample at the end of day 1, or half of it. All right. At the end of the second day, half of that is going to have decayed, and so we're going to end up with half of a half, which is 1/4 of that sample left, or 25%, whichever way you like to do it better. So we're not going to do extensive calculations with this, but you should be able to figure out, depending on how many half-lives have passed, how much of the sample will be left. So that concludes our discussion of transmutation and half-life, and we're going to use these a little bit more in class this week and do an activity to help you understand half-life a little bit better and to graph it and see what it looks like graphically as well.